All right, well, welcome to Module 3, Lesson 1, and I am really excited for this particular module and getting started with object-oriented programming. Okay, so go ahead and open up your Module 3 project, and you'll see a source folder with the default package as always, and you're going to see a ton of files, okay? You're going to see these Lesson 01 and Lesson 02, along with a bunch of very Star Wars like classes that you see here. These are basically for Lesson 1. All of these are kind of combined for Lesson 1 and 2. You'll see Lesson 1 builds quite a few things, and then Lesson 2 will actually use a lot of the things we built in Lesson 1. So by the time we're done with Lesson 1 and 2, we'll have a pretty robust Star Wars universe that we can do some really interesting things, have some fights with some simulated battles and things like that. This organization is really poor. As you can see here, we have all these different files, 1, 2, 3, 4, 5, 6, 7, 8, 9 different files, and we kind of just stuffed them in this one folder in this thing called a default package. We are going to take a look at packages and package organization a little bit later in this lesson, so we'll start to organize this stuff now that we are actually creating a whole bunch of files. But what's really neat, object-oriented programming is all about taking our programming language and being able to build structure. So up until this point, we've had a few different variables in our tool belt, right? We've had all these primitive data types, so integers, doubles, chars, booleans, right? Those are the four main primitive data types that we typically use. On top of that, we also have something called a string. We have arrays and array lists. So we can, if you've made it through modules 1 and modules 2, you've hopefully seen, hey, we've been able to do some pretty neat stuff with just those primitive data types and array lists and strings. But if you want to be a really powerful programmer and a really good programmer, and you want to really start to develop and model complex systems, you really need to have your mind wrapped around object-oriented programming. Object-oriented programming basically allows us to create variables of just about any type. We can create our own data types, so to speak. So instead of just creating a bunch of integers, we can create a house or an automobile or a card. If you recall from some of the earlier module 2, we did a lot of card examples towards the end of that. We had a card, and we said a card was basically represented with a string. And if you think about it, that string actually had two pieces of data in it. It had the club suit, right? Clubs, diamonds, spades, and it also had the club number, 1, 2, 3, or even Jack, Queen, King. That's actually two pieces of data. We just kind of smashed them into one variable called a string, right? So we could actually make our own card data type that actually had those two pieces of data as two separate variables within that one object. So as we begin to develop this example, I think you'll really start to see the power of object-oriented programming. But let's go ahead and get started and kind of motivate what we're going to do with in Lesson 1. So I'm going to open up Lesson 1, okay, and this is basically what we have to start off with, okay? Looks pretty much like everything we've always seen before. If you look at our main, you'll kind of see the general flow of our program. Okay, what we're going to do is we are going to create a number of humanoids. Okay, just like we've been able to create ints and doubles and floats and things like that, we're going to create humanoids just the same as new variables. We're then going to create a robot, so we're basically going to create humanoids and robots in our kind of Star Wars galaxy, so to speak. Then we are going to add each person or each humanoid to an array list to be processed. We're going to process everyone in the Empire DMV line, a very ominous thing, right? Two very ominous things, actually, DMV and Empire. DMV, if you're unfamiliar with that term, Department of Motor Vehicles, is the place we all go to get our driver's licenses or registrations for our car. Very unhappy place. Pick two random customers from the line. Okay, so we're going to pick two random customers, and then, those customers are so unhappy with their DMV experience that they're going to fight. Okay, so we are going to wrap a little bit of variable data and methods around this concept of a humanoid, and then later on a concept of a robot. Okay, so we have this class, okay, public class Les1, and this is every class we have created up until this point, or you've been given, right? If you just kind of got all this code from Git, the templates from Git. All these classes have this main in them, okay? And they're not really representing some object as we know it, okay? If you just think about the word object in the human language, you typically think about something you can hold in your hands or touch, right? It has kind of a material matter to it, right? If I pick up a pen from my desk, I am holding an object, right? That object is a pen. If I pick up a bottle of lotion, that's an object, right? It's a specific type of object. And so that word object-oriented programming is very intentional, right? An object you typically think of as anything I can really represent, I can hold in my hands. So a humanoid, right? I maybe am not able to necessarily hold a humanoid in my hand, but certainly if I was big enough, I could, right? It has a weightiness to it, a matter to it, right? And in terms of kind of scientific matter to it. So that's going to be a different type of class than we're used to, right? We're just kind of used to creating these classes that really we just kind of did it because we have to. That seemed to be the syntax that we needed to get up and running to call this main method, which would basically start executing our code line by line by line. So we are actually going to create something called a new class, and our new class is going to be a humanoid, right? A humanoid is an object. A human is an object if you think about it in the English sense of that sentence. So in order to create a new class, now I already have a humanoid class created for us. You imported all this stuff from Git, right? So you can see just so you can have a lot of the commenting already done for you so we don't have to spend a lot of time writing comments. But I want to go ahead and show you how you would actually create a class from scratch in Eclipse. It's very simple. And basically on our in our project, you would simply right click and then you would go and click on new and you would click class. Okay, now I'm just gonna go ahead and type like humanoid 2, right, just to kind of mimic what we would be doing. Humanoid 2, and then you can actually just click finish. And I want to just point out one thing here. If you check this box, public static void main, it'll basically add to it. I'll go ahead and just create it. You can just kind of pause, don't actually click finish yourself. But if I click this will actually create a new class, right, with that basic boilerplate, and then it'll add that main method. That way, if I wanted to run this as its standalone program, I could, say hello from the humanoid class. Okay, and now I basically have my own standalone program, so to speak. You can see it will run that code. If I don't check that box, it's basically just going to create this. It's going to just create this public class humanoid without that particular public static void main in there. So I'll go ahead and I'll delete this file and I'll go ahead and go through that process kind of where I left you hanging. So again, I'll say new class humanoid 2, and then with making sure that public static void main is not checked, I'll go ahead and click finish. And you can do generate comments if you want, but it's kind of up to you. Okay, and that will get us that public class humanoid 2. And if you look at my original humanoid, which is what you imported, you can see that's basically all it is. It's just public class humanoid with an open and closed parentheses. And I just have a ton of comments in here to kind of lay out the groundwork for what a class really is and what are the basic components of a class. Okay, so if you did create that humanoid 2, go ahead and delete it. We won't be needing it. At any point throughout lessons 1 and 2 and any other lessons I happen to create in the future, if you want to create a class, that's how you'll do it, right? I just kind of give you these these templates by default. Okay, so if we actually think about a humanoid, the first thing to think about is what are the different properties that make up a human? Okay, so let's actually, before we jump into our specific example, let's broaden it up. Okay, if I want to compare several cars with one another, what are the different properties that I would consider? Okay, well, you might consider the make and the model, right? The first thing you might do is you might say, all right, well, I like Jaguar. I like Jaguar, and maybe you like Chevy. You're a Chevy man, so to speak. And maybe the next person likes BMW, right? It would be very reasonable to say, well, I have a car, and that car is a BMW, right? Or I have a car, that car is a Jaguar. I have a car, that car is a Ford car, right? And that basically what I'm giving you is I'm giving you the make, so to speak, of the car, the manufacturer. That's one property, right? A car has a property of the manufacturer, and if I'm comparing 2 or 3 different cars, the manufacturer of those cars may be different. Okay, well, another thing I might consider, I'll just kind of write these down, right? I'll call this the make. Another thing that I may consider is the color, right? Well, I like red cars, you like blue cars, right? The color, the model, right? If we're talking Ford, is it an F-150? Is it a Mustang? Is it a Focus? What is it, right? These are all different properties of cars. And if I had literally 2 cars in my garage, I could distinguish those 2 cars by their properties. Okay, and this is what object-oriented programming is all about. It's about being able to create objects that have a number of different types of properties, and then we can create multiple objects which differ in their properties, right? So I can have a garage with multiple objects or multiple cars, and those cars differ in their properties in that they may be different colors, different makes, different models, different engine types, and so on and so forth. Okay, so with that in mind, let's go back to our humanoid example. Okay, if I have, let's just think of it human, right? If I just had, let's say I had a room full of 10 humans, right? And I wanted to distinguish all those humans from one another, how might I do that, right? What are some of the properties that I would consider, okay? And you want to think about this in terms of every human has these properties, but the value that each human has for these properties may be different, right? So you wouldn't necessarily want to say hair as a property, right? Although it may be, true that some people have hair and some people don't. But most likely you want to say hair color, right? Because a human by nature, at least, almost always has hair. But it's the hair color that really distinguishes me from one other person, right? Me from you, so to speak. Right? I have brown hair. You may have black hair or blonde hair, something like that. So hair color would be a good property because almost every human has some particular value for that property. Age is another one, right? Age is a great one, or birth date, right? Every person has an age or a birth date. Now, our birth dates and ages are all different, but we all have an age or a birth date. Height, weight, place of birth, name, these are all great, right? A unique government identifier. And the United States here, we have the Social Security number, right? And whether you're from the U.S. or you're from another country, you're going to have probably some unique identifying number. So with humanoid, what we are going to do is we're going to decide, and it's completely up to us in what's relevant for our particular program, but we're going to decide what type of information we want to keep on a human or about a human, and basically, these should be properties that differ from, or at least can differ from, one human to the next. So I'm going to go ahead and create a few properties similar to what we had talked about before. So I'm going to go ahead and create name. I'll create homeworld. Okay, since this is Star Wars, and it's typically not a safe place when you're traveling around, we're going to have an attack and a defense. Okay, so we'll start off with this. We'll start off relatively easy. We're just going to have a human, and each human has basically 4 defining properties: their name, where they're from, their kind of basic attack method and their basic defense method. Okay. Now, typically, a class is made up of a number of instance variables. So what I'm really doing is I'm going to smash a number of instance variables together, and those instance variables are going to basically combine together are going to define my class. All right, I can have, for instance, if I have two humans, I may very well have two humans named John in my world. All right. But one John is from planet Earth and one John is from planet Mars, so to speak. So that's how I might distinguish those two Johns, or maybe their attacks are different or their defenses are different. Now, as you can imagine, 4 properties is not really enough to distinguish all the people in the world, but for the sake of our program, that's what we're going to use, obviously, to kind of keep things relatively simple. Okay, so the question might become, well, what primitive data types would I use to represent these 4 pieces of data? Okay. Well, a name, hopefully you can guess, would be string would be a good data type. Okay. Now again, string is not technically a primitive data type. It's actually an object, just like a humanoid is an object. But because it's so prevalent in programming and because it's basic enough, I kind of typically lump it in with those primitives, but it's not technically a primitive. Okay, so I'm going to put a semicolon to kind of almost I'm just going to declare that variable there. Okay, homeworld, again, string, right? Now attack and defense can go, put my semicolon there, attack and defense can go in a number of different directions, but I'm actually going to keep both of these as strings. Okay, now I will say, we're going to stop right here, at least for a little bit, with our instance, with our properties, okay, our human properties. But later on, we will create, in this class and or other classes, we'll create properties that are like integer data types, so using the actual primitives. And we're actually going to have other objects. So what we'll eventually see is that our humanoid actually has a property of a robot as well, which will be its own brand new class, as you see over here in my my coding files over here. But we'll get to that later. I want to start off very basic now, and we'll come back to that in a little bit. Okay, so I have these 4 properties, and there's typically something called an access modifier that we add right here. But I'm gonna talk about that, spelled private wrong. I'm gonna talk about that in just a little bit, but I want to kind of leave that there for us to start off with. Okay, I have defined now the properties for this humanoid. Okay, and these properties, I've been using the word properties because it's likely the most relatable term that is used to describe these things that are familiar with. But in Java, we technically and typically call these instance variables. Okay, they're variables just like any other variable that you've created through the first 2 modules. But we add this word instance variables to them because from one instance of a human to another, the values in these properties can be different. Right? If I created a humanoid named Amy and a humanoid named John, I may very well have a property such as like a Boolean. I could say Boolean is male, right? To distinguish the gender. So John might have would have the property is male, and the value that he would have would be true, right? Is male. Whereas Amy would probably have the value false for is male, right? So from one instance to another, right? John is an instance of a human and Amy is an instance of a human, right? So their instance variables basically allow that from one person to the next or one instance to the next, that these variables can take on different values. Okay, so I'll leave those 4 properties there. All right. And there are a number of different pieces and things that we typically do in a class to kind of make the class work. But this is really the heart of my class. It's the properties. It's the instance variables. What we'll do from here is we'll actually create what's called a constructor. We'll talk about default and overloaded constructors, getters, setters, and then we'll override a few methods. We'll talk about what that even means in the first place, but the toString and the equals method. Okay, all of these things, what we'll see eventually, all of these things can actually be generated automatically from just these 4 lines of code right here. Okay, we'll do that later on, probably when we create our next class, the robot class. But for now, we'll go ahead and just kind of keep this as is. I'm sorry, what I meant to say is we'll actually write all this from scratch. Okay, so what I want to demonstrate now is that we have this humanoid class, and we have my lesson 1 class over here. Okay, now when we get to the point where we have a program that has more than one file, I can only have, I typically have one file that has a main in it. Okay, and that main will call some code, and that code can actually start accessing code from another file, such as this humanoid file. Okay, the file that has the main in it, I typically call the client. Okay, and then any of the other files I might call some kind of model classes. Okay, the client class, this class with the main, is called the client class. Okay, so in my main, again, this is where I have the main method, or in my client classes where I have the main method. This is where I can really start executing my code. Okay, so if I open up lesson 1 and I play this, you'll see all it really does is it prints out this learn basic object-oriented programming concepts. Okay, now just occurred to me that robot's probably not a great name for a class, so I'm actually going to go ahead and rename this really quick. We're going to use this class. I'll for sure make sure that when you import this from GitHub, it'll already be named as droid. So if you were a little bit confused, not seeing robot, you'll see droid by the time you download this. So I'll go ahead and rename this. Okay. So just small detail there. But, okay, where were we? Oh yes, okay, so we were basically just demonstrating that when I play this program, it's just playing this basic print statement. Okay, so what I want to do here in this client is I want to basically, now that I have this humanoid, and this humanoid has these 4 basic properties or instance variables, I want to see if I can actually create a humanoid. Okay, so if I come in here and I say humanoid, okay, so humanoid is now actually a data type. Now I have a long way to go to really complete this class, but I in some sense actually have created a new data type called humanoid, right? Just like int is a data type, like string is a data type, I have a humanoid. Okay, and maybe I will call this humanoid Dan, or Dr. Dan, okay? And I'm just going to do a semicolon there, okay? So essentially what I've done is I have declared a humanoid called Dr. Dan, okay? And what you'll see is I actually don't have any compiler errors, okay? Now, Dr. Dan has a number of properties, okay? What's really neat now is you can see you can actually see that attack, defense, homeworld, and name. Okay, so let's say I wanted to actually set my name. I could say drdan.name equals Dr. Dan. Okay, now I have an error. All right, if I hover over it, says the local variable Dr. Dan may not have been initialized. Okay, so what I did right here is I declared a humanoid, and I just, kind of gave it a variable name of Dr. Dan. And then I took this variable and I tried to change the name of it. Okay, this is equivalent to okay. Let me actually show you what the problem is, and I'll kind of explain the rationale, kind of the real world analogy that I have for you. Okay, but let's just do the quick fix and see what happens. Okay, and it gives me null. Okay, and great, right? My code my code is now compiling. Let me go ahead and run it. Okay, and I get this null pointer error on line 35, right, which is this line right here. Okay, at this point, what I'm doing is I'm saying, hey, I have this humanoid, I'm going to call this variable Dr. Dan, and it is null, right? It's nothing. And then when I say Dr. Dan.name, I'm basically trying to change the name of this humanoid, okay? Or, I could try to do any of these other ones, right? I could say Dr. Dan dot attack equals, I don't know, keyboard smack. Okay, keyboard smackdown. Okay, so I'm trying to set these properties of this variable, but the variable doesn't really exist yet. Okay, so I kind of relate this to when a baby is born. Okay, so oftentimes when a woman gets pregnant, a lot of people go around and they say, hey, I am pregnant, I'm going to have a baby, right? But I can't actually feed that baby yet, right? It's still kind of in the mama's tummy. So this would be the equivalent of like this statement right here is declaring, right? When I declare, hey, we're going to have a baby, right? You have these big baby parties and whatnot, right? Hey, everyone, I'm going to have a baby, or baby announcements. That would be when you declare the variable, okay? But until the baby is actually born, right, you can't necessarily do a lot with it, right? You can't play with the baby, you can't feed it, you can't really talk to the baby, and expect to get like too much interaction or anything like that. So the process, that kind of the equivalent of the baby, once the baby is born, then you can actually name it, right? You can officially write down on a birth certificate the name of that baby. But until that baby is born, right, you can give it a name, but it's not official, right? You could change it at any moment. Oh no, I actually don't like John anymore. I want to change it to Jim, even though I've told everyone it was John. I think Jim's going to be the name. You could do that, right? Once the baby's born, then you put it on the birth certificate. The baby, right, has not just been declared, so to speak, it's actually been initialized or constructed, okay? And that's very mechanical words for the actual Java definitions, okay? So before we can actually change values for this variable, we actually have to construct the human, okay? We have to construct it using a constructor. Okay, so if we go to our human class, the next thing we typically do after our variables is we will create a default constructor. Okay, now a constructor basically works like this. I basically take the name of the class and I just do an open and close parentheses, an open curly brace, and a closed curly brace. Okay, and again, we're going to come back and add a little bit more. We'll add what are called access modifiers to these a little bit later. But for now, I'm going to kind of leave them out for the sake of simplicity. Okay, so what a constructor does is it essentially says, hey, when this human comes into existence, right, and going back to the baby example, right, when this baby comes into existence, what should it be called, right? What should the name be? Where's the home world? What is the basic attack? What is the basic defense? Okay, so this default constructor, what it does is it basically says, hey, if no one else is speaking into what this person should be called or telling me where the person's from, if I could just set some default values, what would they be? Okay, so maybe for my name, I would say something like this. I would say name equals no name. Okay, and notice that this name, when I click on it, it highlights up here. Okay, you can see this name is the name that we see up here. Okay, so name, the string, since it was defined directly in the humanoid class, it's good anywhere in the humanoid class, even within some other methods or this kind of interesting new constructor thing that we're looking at. Okay, So I basically just want to give some values that I just kind of come up with to say, hey, if no one's actually giving me a name or a homeworld or an attack or a defense, what should those be? Okay, so maybe homeworld is equal to, let's just say, Earth, right? And then attack, okay, probably basic humanoid attack would be to arm swing or something like that. Okay, and then the basic defense would be to cry. Okay, I have a 2-year-old, so I'm very familiar with this. Okay, so now we have a humanoid, and it has a name, it has a homeworld, it has an attack, and it has a defense. Okay, at least if I create a basic humanoid. So I have this thing called a constructor. All right. Now, this should start to look a little bit familiar to us, right? So in my humanoid, when I say Dr. Dan, instead of saying null, I want to say equals new humanoid. Okay. Why does this feel a little bit familiar? Well, it hopefully feels a little bit familiar for something like this. When I created an array list, and I might maybe said string names or something like that equals new array list. I put the data type, right? And I always ended it with this open and close parentheses, right? If I imported array lists, these errors would go away. We have the same thing here, okay? Anytime I have an object, I always have to, when I'm creating a new object, I use this keyword new, and there's always some kind of open and close parentheses on the end, and then the data type in the middle. And that's all I'm doing here, right? I'm declaring this humanoid, which has a variable name of Dr. Dan, right? Or the variable is called Dr. Dan. And I'm creating it by creating a new humanoid data type, and I'm not passing in any parameters to initialize the values of that particular humanoid. Okay? So now what we'll see is when I run this code, it'll actually run without giving me that kind of atomic bomb blowing up in my face, so to speak, without that null pointer exception. Okay? Now, what's interesting is let's actually jump into the debugger and kind of see what's happening. If I set a breakpoint here on humanoid Dr. Dan, then I click on the bug up here. What you'll see is when I hit F6, I have Dr. Dan over here, and if I actually expand this, you'll now actually see this Dr. Dan has a name of no name, a homeworld of Earth, a defense of cry, and an attack of arm swing. Okay, and then if I run this line of code, what I'm actually doing is I'm going to overwrite the value, Dr. Dan's name value to be Dr. Dan instead of no name. And that's exactly what you see right here. Likewise, if I continue, right, and I do Dr. Dan.attack, I now have overwritten the attack from, I think it was the arm swing, to the keyboard smackdown. Okay, so what's really neat now is I have this one variable, Dr. Dan, that represents multiple things. It's basically representing 4 things that are kind of connected all to one real life object. Okay, so from there I could go ahead and print out some, I could print out some of these values. So system.out.println, okay, or maybe let's do a printf. Okay, and I could say %s has an attack of %s. And then that first parameter, I'll do a new line here as well. That first parameter is going to be drdan.name. And the second parameter is going to be drdan.attack. Okay, so there we see Dr. Dan has an attack of keyboard smackdown. Okay, so pretty cool. So this is the default constructor. Okay, so now let's go on to one more constructor, and that is the overloaded constructor. Okay, so the overloaded constructor is very similar to the default constructor, so I'm actually going to start off exactly the same way. Actually, I typically will actually copy and paste the default constructor. But what's different about this is called the overloaded constructor, is the overloaded constructor actually takes in some parameters, okay? And almost always, at least when we're first starting out with coding, the safe thing to do is create an overloaded constructor, which basically takes in one variable, takes in one parameter for every single instance variable. Okay, so typically what I do is I look and I see, well, I have the name, the homeworld, the attack, and the defense. All right, well, that means I need a string name, a string homeworld, a string attack, and a string defense. Okay. But what you can see is that just happens when I name all these variables. I basically now when you see when I click on name, it's highlighting this name inside the constructor, but it's not actually highlighting the names up here. So I actually just created a new version of name, homeworld, attack, and defense that aren't connected to the ones up here. Like you saw when up in my default constructor, the name here was connected to my instance variable, my humanoid property. So what I typically do is I will actually just kind of add a P in front of all these and then uppercase that first letter. P stands for parameter in this case. So I'll go ahead and add P and then the capital A and then P and then capital defense. Okay. In the very basic overloaded constructor, all it does is it basically allows someone writing code in the client to pass in these parameters, and I'm just going to use these parameters to initialize the properties of this person. Okay, so instead of saying name equals no name, I'm now going to say name equals p name, and homeworld equals p homeworld, and attack equals p attack, and then defense equals p defense. Okay, again, do remember control space will get that auto suggest up for you, and you can just hit enter a lot of times to make your typing a little bit quicker, a lot of it quicker, really. Okay, so you do see there is one more parameter up here, probot, but we're gonna save that one for later. We'll do that in another sub portion of this lesson. But for now, let's just assume we have these four fairly basic string properties, these string instance variables. Okay, so with that said, we actually now have a new humanoid. Okay, a new humanoid overloaded constructor. Okay, so what I can do is I'm actually going to change this humanoid. I'm going to say Alt-Shift-R. Okay, and I'm going to call, actually let's leave this one here. What I'm going to do is I'm going to create a humanoid generic person equals new humanoid. Okay, and then I'll go ahead and I'm going to copy this line and I'm going to paste it up here. Okay, and then instead of Dr. Dan .name and Dr. Dan .attack, I'm going to overwrite Dr. Dan with generic person. Okay, so now I have generic person .name and generic person .attack. Okay, so let me go ahead and I'll comment out this Dr. Dan code, and we'll just run this one. Okay, no name has an attack of arm swing. Okay, again, what's happening here is that if I jump into the debugger, you'll see that my humanoid, what it's really doing, if I dive down into this code using the F5 key, you'll see that it'll actually, after a little bit, sometimes you have to hit F5 and F7 a few times, it actually is going to jump down into the humanoid constructor. Okay, and you'll see over here the word this. Okay, this is a keyword in many programming languages, especially in Java and C++. I think in Python, the word self is what they use for this concept of this. Okay, we're going to explain what this is kind of throughout this lesson and the next. It's kind of an overloaded word because I tend to use the word this a lot, but this is a technical keyword. You'll see it's actually a Java keyword that will highlight differently when you actually write the word this out here. But the way that I could explain it right now, and again, I don't know that you'll probably get it quite yet, but hopefully you'll get it with time, so don't worry if you don't quite get the concept of this yet. But I am getting ready to create this new generic person, and I'm basically kind of diving down deep into the generic person, so to speak. Okay, and I'm basically saying, all right, well, this human's name is no name, and I execute that line of code, and I set this person's name to name. This is relevant inside of a class itself. Okay, remember we have, let's go back to the car example. Let's say I had two cars in my garage. Let's say I have a red Ford Mustang and a black Jaguar. If I literally get inside of the Mustang, I would say this car is red, right? And that has a meaning. You would know that I meant that Mustang, even if I didn't like point at the Mustang, because I'm inside of that Mustang, right? So this car is red. Then I get out of my Mustang and I get inside of my black Jaguar, and I look at you and I say, this car is black, right? You would know exactly what I meant. You would know I was speaking about that Jaguar. Okay, so it's the same concept here. When I say this, I'm talking about, in the case of the cars, I'm talking about the car that I'm inside of. In the case of the humanoid, I'm talking about the humanoid that I'm inside of, so to speak. Okay, so and the idea is I may be sitting inside of my black Jaguar, and right next to me there's another car, right? So that car, I might say that, right? But that's not really a technical term in Java. This is. Okay, so anytime I'm inside this class, I use that word this to basically make it very clear I'm talking about the particular instance that I'm working with at the moment. Okay, so that probably didn't make sense to you at this point. Maybe it did a little bit, but if it doesn't quite yet, don't worry. We can get pretty far without you having like a 100% understanding of the this keyword. But nevertheless, right? So I'm in this this particular humanoid, and then I'm gonna basically change all those values with that default constructor, and then I jump out of it, and then I'm able to basically grab the name from that generic person, and I'm able to grab the attack from that generic person. Okay, and that's why we see this getting printed out. All right, so now let's go ahead and I'm going to bring my humanoid Dr. Dan back, and now I'm actually going to delete those two statements right there where I was setting the attack and the name. Okay, and I am going to actually pass in some values to my humanoid constructor. Okay, now what I typically do is I look and I see, well, what values were we passing in here? Well, we were passing in a name, a homeworld, an attack, and a defense. Okay, if I actually go ahead and kind of delete this and write it from scratch, new humanoid, and I do an open close parentheses, I believe I could do a control space just after typing humanoid. And at this point, it'll basically show me, hey, there's two options. You can create a humanoid like this default humanoid, which is just going to give you, these default values for name, homeworld, attack, and defense. Or you could call this overloaded constructor, which takes in a name, a homeworld, attack, and a defense, and it basically allows me and the client to set these things up. So I'm going to go ahead and just double click that or hit enter. And this is nice because it basically shows you what it's expecting, right? Oh, a name. Okay, well, the name that I'm going to choose is Dr. Dan. Okay, the homeworld is, let's say, planet Earth, just to make it a little bit different, right? Because Earth is the default constructor's homeworld. Okay, my attack will be, in fact, the keyboard smackdown. Okay, and my defense will be the, I don't know, my creativity is suffering, so I'll do the keyboard shield. Okay, and then we'll do the semicolon there. Okay, so now, again, what I can do is I can uncomment this, and when I print it out, you'll see Dr. Dan has an attack of keyboard smackdown. All right. So again, let's jump ahead in this code. We'll debug it a little bit. So when I set my breakpoint here on line 37, if I click on the bug, what we'll see is when I dive into this code, F5, you'll see that now I have all these particular parameters that I passed in, Dr. Dan, planet Earth, and so on and so forth. And I have this object has not been set yet. It's like I'm sitting in that red car, but now I'm on the factory line, okay? And the I'm sitting in that red car riding down the conveyor belt in the Ford factory. Sorry, it's not red. I'm sitting in that Mustang, and I'm riding down the conveyor belt in the Ford factory. And someone comes up to me and says, hey, I am going to paint this car red. They press a button, right? And then this car that I'm sitting in now becomes red because the robots come and spray paint it candy red. So that's basically what's happening here. So you'll see that the this values are going to get updated with those parameter values that got passed in. Okay, and then of course I could come back here and I could change any of these. So now I can say Dr. Dan dot name. You know what? Dr. Dan equals Dan. Okay, you know what? You're on module 3. I think we know each other pretty well. You really don't need to call me doctor. It's just a funny title that people give me. Dan is fine. Let's just go with Dan from here on out. So I can basically copy and paste this system.out.println one more time, and you'll see that after that line of code, Dr. Dan.name equals Dan. Now when I print out Dr. Dan.name, it's just Dan. Okay. All right. So up until this point, we have done the very basics to get a class up and running. Okay. We haven't set things up quite right or quite to the level that we want to, but this is a good stopping point because we've talked about what a class is. We've talked about properties or instance variables, and then we've talked about constructors, a default constructor for when I don't really know what the properties are going to be, and we talked about a overloaded constructor for when I know what all the properties are going to be. So we'll talk we'll pick it up from here in the next lesson.